Hey folks, welcome to the Neo4j stream. My name's Will, and today we're going to be looking at GraphQL authorization. So sorry for missing last week. I had quite a bit of construction going on outside the house. They're still going. They're about a block away now, so hopefully it's a bit more manageable. So we've been working on building up this real estate search application over a few weeks, and we had a basic data model. We were able to import some data, view it on a map, query that through GraphQL, and I had a lot of questions asking about how do we protect our GraphQL APIs. So how do we add authentication and authorization to our API and to our application as well, right? So for the real estate search app, we'll need to think about this both on the front end and the back end. And what I thought it would be helpful to do in this session today is take a step back from our real estate search application and just talk a bit about GraphQL authorization specifically. So specifically today, we're going to focus on the options for GraphQL authorization. Look just mostly at the back end. And then what I'd like to do next week is then take what we found exploring today and then add that to our real estate search application, adding authentication and authorization to our search app. Cool. So, so I think what we'll do today is maybe just start a new GraphQL API, connect that to Neo4j, and then look through a couple of different ways that we can protect that API and add authentication and authorization to it. Well, mostly authorization. So with that, I think what we'll do is start a new project. So make this a bit bigger. So I'm going to do npx create GRANDstack app. Let's call this GraphQL Auth demo. And this is going to pull down the latest version of the GRANDstack starter project, which we'll just use the API piece of that. We won't use the front end piece of it, but that's fine. Oh no, it looks like we have an error here. What does this say? We have exceeded rate limit. Well, let's try one more time. Looks like we got a GitHub error there. So what the Create GRANDstack app does, it's a CLI that downloads the latest release of this project. From GitHub, it looks like there's some issue with the GitHub API. So let's see. Well, let's see, why don't we just download the release itself. And we'll rename this GraphQL Auth demo. And that's going to be in downloads, GraphQL Auth demo. I'll have to explore what was going on with GitHub there, but you can also just clone this project directly from GitHub or download the release like we did. Okay, so we're just interested in the API piece of this. So we'll go into the API directory and open this up. And VS Code, sure, you can have access to my downloads directory since that's where we saved it. Okay, so let's get a terminal. And the first thing we'll do is npm install to install our dependencies. And then while this is running, let's switch over to Neo4j Desktop. And let's go ahead and create a new database. The latest version that I have downloaded, that should be fine. GraphQL Auth demo and a password. We'll need to know the password so that our GraphQL API can make authenticated requests. So let's start this database, and then there's a .env file in our GraphQL API project here. And we're going to make sure that we have the credentials for our database here. So it's a bit bigger. There we go. So the Neo4j URI is bolt localhost 7687. That's the default to connect to a local database, which we're doing. Default username is Neo4j, and default password is let me in, which is exactly the password I used here. So looks like I don't need to make any changes there. Let's take a look at source schema.graphql. And why don't I have syntax highlighting there? I have a new computer, so I don't have everything quite set up yet. So let's get the GraphQL extension for syntax highlighting. Let's see, which one of these? Does anyone have a preference for the best GraphQL? Oh, a visitor on my desk here. Let's stay off the keyboard, please, Jenny Cat. Thank you. Anyway, oh, now she's biting. Okay, we'll have to put Jenny Cat in timeout. Just a sec. Okay, Jenny Cat is in timeout for biting my legs. Don't appreciate that. Jack says hello. Hi, Jack. Thanks for joining. Okay, let's install the GraphQL VS Code extension. This one will give us syntax highlighting for GraphQL files. There we go. Okay, so here's our schema. We have users, businesses, reviews. We have some custom queries and custom mutations. Cool, that's perfect. So let's go ahead and start our GraphQL API. So we'll do npm run start. And we get an error that there's no procedure with the name apoc.schema assert. So what's going on there? Well, if we take a look at index.js, what we're running here, So this is starting a GraphQL API powered by Neo4j GraphQL.js. So that this is a library that has the logic for making requests to the database, generating Cypher queries from GraphQL, Neo4j driver to connect to Neo4j using Apollo server for our GraphQL server layer. Then we also have this initialize database that we're pulling in from initialize. And if we take a look at initialize, we can see that we're running here a Cypher query that says call apoc.schema.assert, and then it is giving a list of labels and fields. So what this is doing, this is a call to the APOC standard library for Neo4j, basically to ensure that we have set up some indexes and constraints before the database comes online, before our GraphQL API comes online. But it uses the APOC library. So that's what our error here is. It's saying that, hey, we have not installed the APOC library. So let's go ahead and do that in Neo4j desktop. So we're going to click on Manage for our database, Plugins, and then Install and Restart APOC. So that will add the APOC procedure library to our database and then restart our database to register that. Okay, so that is online. Let's open up Neo4j browser and we can just verify that we did indeed install APOC. So now we can say call dbms.procedures, and this will tell us what procedures we have installed in this database, and we can see we have a lot of procedures under the APOC namespace. Cool, so let's try that again. npm run start. And now we say GraphQL server ready at localhost 4001/GraphQL. So let's check out localhost 4001/GraphQL. Okay, so here is GraphQL Playground. So we can click on docs and you can see the entry points into our API. So we can query for users, businesses, and so on. So here's a query. Let's search for users and get all their names. And of course, we have no data that we get back because we have no data in our database. So let's solve that problem. So I'm going to switch back to Neo4j browser and run :play GRANDstack. This command, this :play command, this is one that we can use to load these browser guides in Neo4j browser. This one is fairly simple. It's mostly just linking a Cypher script for loading some data. But there's lots of others. For example, :play movies gives us the movies data set. I think there's :play Northwind, which tells us how to work with the Northwind graph in Cypher. So these browser guides are really handy. When you first load Neo4j browser, you see this :play start browser guide that runs. It links us to some other browser guides and so on. Anyway, so :play GRANDstack links us to a browser guide that has this embedded Cypher query. This is just loading some data from a CSV file and then creating some data in the database. And this just happens to match the GraphQL schema that we have defined in the starter project. We could also load the same data set. There's a seeddb script, which runs these mutations, which basically it loads the same CSV file, but then runs these GraphQL mutations to create the data in the database rather than doing it in Cypher, but it's the same data set either way. Cool, so we can now verify we have data. If we, let's say, match in return count in, we can say, yep, we've created 36 nodes, so not a whole lot of data, but enough to play around with. Now if we run this GraphQL query again, we can see that, yep, we have a handful of users. They have some user ID. They've also written some reviews of businesses and so on. Cool. Okay, so now we have some data coming from Neo4j through our GraphQL API. And right now, anyone can access this GraphQL API. It's just protected. It's just unprotected here. Anyone can just run a query against it. What we want is to add some authorization rules to say, hey, no, you have to be an admin user, or you're only able to see your own data, things like that to start to protect the API. So let's take a look at the GRANDstack docs. And if I search for authorization, there's this page, GraphQL authorization and middleware, which I will drop a link to in the chat, since this is fairly important for what we're going to focus on today. So authorization in GraphQL is fairly open-ended. GraphQL is very unopinionated about the best authorization technique, and they rather, sort of leave it up to whoever's implementing the API to use whatever authorization technique they deem appropriate. It may be, something that you're just sort of passing through. If maybe your GraphQL API is sitting on top of other APIs, maybe you're just taking an authorization token and passing it down further. But in our case, we actually want to build the authorization layer at our GraphQL API layer. So there's lots of options for how we can go about introducing authorization to our GraphQL API. I think today we'll talk about a few of these, and then maybe we'll take a stab at maybe implementing maybe two different approaches here. So if we look at the docs here on this page, the first option is GraphQL authorization schema directives. So our GraphQL schema, let's jump over to that, schema.graphql, where we're defining our types. This option is to add directives to the schema, and there's three specifically here. So is authenticated, has role, and has scope. So with this approach, what we would do is in our GraphQL type definitions, we would sort of annotate a type or a field to say that you have to be authenticated, whatever that means. We'll explore that in a second, in order to access any of the data, in this case on the user type. We could also do that on the field and say, well, I don't know, to get the user ID, you need to be authenticated. Then we can also add the has role schema directive. And this directive takes an argument called roles, which is an array of possible roles that the user must have. So it could be the case, maybe we want to say the user, to access any of the user data, they need to be authenticated, but then to be able to access user ID, they need to have a specific role of admin. Maybe something like that. Okay, but how do these schema directives work? Well, this specific schema directive package that's built in to UFJ GraphQL JS is called GraphQL Auth Directives. Here we go. And this is a library that, a package that exports these three directives. It is authenticated, has role, and has scope. And they specifically work with JSON Web Tokens, which we'll talk about in a second. Okay, so that's sort of one option, is we sort of annotate our schema to define what the authorization rules are, who can have access to which bits of data, and then we somehow wire that up to a JSON Web Token, and somehow those authorization rules are enforced thanks to this GraphQL Auth Directives package. Okay, so that's one option. Another option is this one here that says Cypher parameters from context. So in this case, this works specifically with the Cypher schema directive fields and types. So for example, here in our schema on user, we have average stars. So this is a computed field. We've defined the logic with Cypher. And in this case, we're not using any arguments in the Cypher query. But with this Cypher parameters from context method, this gives us the ability to inject values into this Cypher query that we've defined in the schema here. So for example, looking at the example in the docs here is a bit more relevant. So here we're defining a current user field on the query type, where we're saying match a node with the label user, where the ID is Cypher params dot current user ID, and then returning that user. So sort of a custom query field searching for a user, and then somehow this Cypher params dot current user ID is injected into the query as a Cypher parameter. So where is that Cypher params current user ID value coming from? Well, in this case, when we spin up the Apollo server instance, we have to define the context object. And the context object can be defined, in this case, with a function. So at query time, it's passed in the request object. So this is the HTTP request object. And here in this example, we're injecting the driver. So this is the Neo4j driver instance. But then if we also create this Cypher params object, any values here will be injected into our Cypher query here. So in this case, current user ID is the value of user.id from the request object. So in this case, maybe we're using some sort of middleware to add a user object to the request before the GraphQL resolver runs. And in this case, at query time, now in our generated Cypher query, we know the value of the user ID, so we can only return the authenticated user. Okay, so that's another option for adding authentication and authorization in the case where we're working with Cypher directive fields. Other more general options are things like inspecting the context object in the resolver itself. This is useful if we're implementing custom resolvers rather than relying on the generated database queries from Neo4j GraphQL.js. We still can use this option with Neo4j GraphQL.js. Basically, what we're doing here is implementing the resolver function. We have some sort of authorization check. This could be, in this case, we're just looking for to make sure that there's a user object attached to the request, but this could be maybe going out to some external system to verify that the user has access to this resource that they're requesting, whatever sort of custom authorization logic we have. And then if we do pass that authorization check, then in this case, we're returning the Neo4j GraphQL function, which will then generate the database query and send the results back. So this is sort of in the case where we still want to rely on that generated database query functionality, but we have maybe some more custom authorization rules that we need to implement. The additional labels directive, this is useful for maybe something like multi-tenancy, where we have an additional label, maybe a label representing the tenant or something like that, that we want to add to the generated database query. So we can define rules here, also leveraging the same Cypher params object from the context object. So in this case, we're maybe attaching a user ID, and we have a label, an additional label on each node in the graph representing the user ID that has access to that node. Then we have middleware options, and this is a wide-ranging option here that gives us a lot of flexibility. In the example here, we're using some middleware, in this case, just to check for an error header. And if we find an error header, then we add that to the request object, which then throws an error when we try to resolve the data. But there's lots of options for adding middleware. Soccer Nuffin says, thanks for the stream. Thanks for joining. Exactly what I've been looking for. Great, cool. Thanks for joining today. Cool, so yeah, so that's kind of an overview of the different options. And just to kind of refresh what we want to do, we talked about some of the various options. Let's see if we can implement maybe a couple of these on the API that we just created, and then figure out how those work. And then what I want to do next week is go back to our real estate search app and actually implement some authentication and authorization functionality to our real estate search app, both on the front end and the back end. Cool, so let's try to get one of these options working. Let's go with the Cypher parameters from context. So let's try this approach first. So let me remove these schema directives that I added. Maybe that'll be our second approach, looking at our schema directives. So is authenticated, oh, and has role. Let's remove those. Cool. Okay, so let's see. So maybe let's add a new query field where we want to return the authenticated user. So, so the case here might be, you know, I have maybe like a profile or dashboard page, and when I'm logged in, I want to be able to see, you know, all of my user information, my user ID, and then maybe all of the reviews and things like that that I've made. So let's add a new query field. Let's call this the current user. This will be kind of similar to the example over here. I think that's fine. Soccer Nuffin says, not sure if you answer questions on the stream. We do, of course. But you have a question about how one would go about using an existing Apollo server with authentication with Neo4j. Yeah, do you mean you have an existing authentication functionality in your existing GraphQL API and you're looking at how to add in Neo4j to that? Or is it more of the case where you have an existing, yes, with JWT? Okay, yeah. Yeah, so we'll cover maybe some areas that are helpful to that today. Yeah, using generic JWTs. So when we get to our schema directives, we'll use just any JWT provider for that. And maybe that will help answer some of your questions on that. But yeah, maybe let's check in once again once we get through that second option and see if that maybe gives you some ideas. Cool. So we're adding here our current user fields. That's going to return a user object, and we're going to define. Oops, my headphones went out for a second. Can you still hear me? Hope so. Hope so. Shout if you can't hear me. Challenge of Bluetooth headphones. Okay, so what we want to do is search for a user where I think we call it user ID instead of ID. Yeah, user ID is some value. So starting out here, let's just hard code something in. So if we go to Neo4j browser, and let's just pick some user random, user ID 1. So where user ID is U1, and return the user. Okay, so oh, we need to restart our API. Nope, didn't pick up that change. Cool. So now, oops, what happened there? Syntax error. Oh, double quotes. We can use a single quote in here, or we could escape it, but just use a single quote. Okay. Cool. So now if we take a look, we have a current user query field. So we can say current user, name, you get back Will, user ID, and maybe all of the reviews this user has written for which businesses and so on. Okay, cool. So that is always just going to give us this user, because we've just hard-coded that value in here. But instead, what we want is to return the actual user that's actually authenticated into our application. I'm going to cheat a little bit and just add a header here. Let's call this user ID. So in the real world, instead of passing in the header the user ID, this would be some sort of token, like a JWT, a JSON Web Token, or we might have some middleware that adds this to the request object. That's okay. This is fine. We'll take a look at JWTs in a second. Okay, so we're passing in the request header the user ID. So instead, if we go back to the docs here, it's grabbing Cypher params dot current user ID. So Cypher params, and we'll just say user ID. Call it that. Do we have, I think we have a watcher script. Is it, oh yeah, start dev, not start. Npm run start :dev. So I think this one, this will have a watcher. Oh, great, and it's also in debug mode. So now when I make changes, yeah, there we go. Now when we make changes to the schema file, those get picked up, and when we run a query, we get the debug output, which is the generated Cypher query. Cool, so that was the one I wanted. Okay, so now when we run this query, it says error, failed to invoke function, afix column, caused by parameter not found exception, expected parameters, Cypher params. Yeah, so our Cypher query here is saying that we're going to pass in a parameter called Cypher params, and I want this user ID to come from my request header here, user ID, but that's not being injected. Why is that? Well, if we look at the docs here, it says that when we spin up Apollo server, we need to specify this Cypher params object in the context object. So let's jump to index.js, and here where we're starting Apollo server, here's the context. We're just hard coding it, passing in the driver, and then this is in the case where we have a non-default database specified. So Neo4j has the ability to have multiple databases, and we may want to connect our GraphQL API to the non-default. So we pass in this Neo4j database value, but we don't need that. We're just using the default database. But instead of passing an object, we can also pass a function here that is passed in the request object. And then our function is going to return the driver object. So that's defined up here. So this is our connection to Neo4j that we're injecting into the context object so that Neo4j GraphQL.js can make requests to Neo4j. But then we also want to define this Cypher Params object, and we called it user ID. So user ID, we're now going to grab from the headers, and we should have a header called, I think I called it user ID. So let's give this a try. Go back and run our query again. Okay, and this time we get Will, and I guess this is me, user ID and reviews, but let's change the text a bit bigger here. Let's change now the header to U2, and now we get Bob's information. And if we send in U3, we get Jenny, and so on. So in this case, we're just grabbing the value from the request header, but note, like we could set this using any logic. So if we have some sort of middleware that's running here, maybe something like passports, if you're familiar with passports, or if we have a JSON Web Token, we can decode that and pull out some of the claims to add the user ID here, and so on. So it's a pretty flexible approach to be able to inject these values into our Cypher statements. Cool. So that's the first approach, which is Cypher parameters from the context object. What I want to look at next is the GraphQL Authorization Schema Directives approach. So that was a case where we're adding these rules by annotating our schema with these schema directives. And these work with JSON Web Tokens. So this says work with JSON Web Tokens and assumes a JWT is included in the GraphQL request header. Okay, so that's going to be something kind of similar to how we're sending this header here, but instead of the raw user ID, it's going to be I don't know, something like this, token, and then some gibberish, something like that. So the client then is going to be responsible for adding that header. So if we're thinking of this in the context of our real estate search app, where we have a React front end, the React front end is going to be responsible for adding that token to the GraphQL request header. And we'll talk about how to do that with Apollo clients next week when we get to that step. Okay, so it assumes a JWT is included in the GraphQL request header, and then the claims contained in the JWT, roles, scopes, etc. are used to validate the GraphQL request, protecting resources in the following ways. Okay, the claims contained in the JWT, roles, scopes, etc. Okay, so let's talk a bit about JSON Web Tokens. There's this really nice site that I like called Online JWT Builder. So, so JSON Web Token is basically a bunch of claims, so a JSON object here that is then encoded into some token. We can encode this one right here. So create signed JWT. So we just get some some token here that we can then use to express these, they're called claims, but that's basically the individual elements in this JSON object. So then when, say, we send this token, in this case from a GraphQL request, or as a header in a GraphQL request, when the API server gets that, they can take this token and they can then inspect the claims and say, oh, well, you are saying that you are user Johnny Rocket, and that you have roles manager and project administrator. Great. So I know now to go apply my authorization rules, and I can then give you the resources that you have access to. How, though, does the API server know that this is actually a valid request, that you actually are Johnny Rocket? And that's where the key comes into. So when we are encoding one of these JSON Web Tokens, when we're taking the claims and generating this token, we use a cryptographic key, and because of public encryption magic, if I have the private key for this, I can then, on the server, I can then verify that someone with the correct key actually did encode these claims, and that it is indeed Johnny Rocket who is making this request. Soccer Nuffin says, so the JWT would need to contain a role array for has role. Yep, exactly. So if we look at our example here, so there's is authenticated. So is authenticated, all that is doing is on the server, it is using a key to decode the token that's passed in. So it's just verifying that this is a valid signed JWT, that it was encoded by someone who has a valid key. So therefore they are authenticated for this API. It's not inspecting any of the claims in the JWT. If we look at has role takes an argument, roles, and so we need to ensure that, in this case, admin is one of those roles. Let's give it role of, I don't know, user and admin. Cool. So, so if we copy this token, and if we go to, we can go to JWT.io, which is another fun online web app for decoding JWTs. We can paste that in, and we can see the claims, and we can see that, yep, this user has role user and admin. Now, this is not, at this point, it's not verifying the JWT because we don't know what the signature is, don't know what the key is, but we have that here. And says, yep, okay, that is verified. That is a valid signed JSON Web Token, signature verified. So in this case, we should give Johnny Rocket access to whatever a user and admin, whatever a user with those roles has in our API. So let's add this to our API. Starting off, let's just say is authenticated. So we'll add this is authenticated directive on the user type. So in order to access any of these fields on the user type, you need to add a valid signed JSON Web Token. And we get an error that says unknown directive is authenticated. So that's because we need to declare this directive. We can't just go adding any random directives to our schema without declaring them. And so to do that, we need to update the configuration object in our call to make augmented schema. So make augmented schema, this is how we use Neo4j GraphQL JS to generate database queries. Yep, and Soccer Nuffin has exactly got it for me here. Yeah, so we can add a schema directives object, or we have this to the call to make augmented schema, but we can also add in the config object. This is kind of a helper for declaring these, where we just sort of enable these. So is authenticated is true. So what Soccer Nuffin posted here is something like adding a schema directives key and then adding is authenticated and the is authenticated directive. And that's true, that would work. To do that, we would have to do something like install this GraphQL Auth directives library, and then it would be look something like this. But because these are bundled in Neo4j GraphQL JS, we can just use this nice helper to just enable this is authenticated. Cool, so now our server restarted, and now if we go here, let's try to request all usernames. And we get an error. Cannot read property cookies of undefined. Well, the error message is not really very helpful. What it's saying though is that we don't have access to this resource because this is not an authenticated request. So there's a few more configuration things we need to do. So we need to declare the secret somewhere. So let's stop our server and we'll say export JWT secret. And this is the key here that we use to encode the token. And then when we make the request, we want to ensure that we're sending that in the headers. And if we look at the example, so we're adding an authorization header as a bearer token. So I think the format that we want is authorization for the key, and then the value is bearer, and then let's grab our token. Let's give this a try. Oops, failed to fetch because I need to restart our GraphQL API. Okay, server ready. Read property cookies of undefined. So let's see. What did we miss here? We added the isAuthenticated schema directive. We set the JWT secret environment variable. We enabled our auth directive. By default, we look at roll. Yep, that's fine. You don't need to override this. Declare a value for auth directive's roll key. Yep, so we don't need to do that. We did this. We're not yet working with auto-generated queries and mutations. We're not doing custom. Yeah, so what's going on there? Can read property cookies of undefined at verify and decode token in our auth directives. Interesting that it's talking about cookies. Let's take a look at the code here and see what's going on. So source index. So here's the isAuthenticated directive. And there's the declaration. This is the object. We first decode, verify and decode token. And then we call next. So you can see, by the way, this is how we implement schema directives. So this is using the GraphQL tools, schema directive visitor package from the GraphQL tools package. And this makes a really nice way to sort of build these custom schema directives. A schema directive is basically anything that is defining any custom logic on the server, right? So in this case, this package is saying do something with custom auth rules, but we can define any sort of custom logic in these directives. But anyway, let's go back to our error. So properties of undefined field.resolve. Is there anything working with cookies here? Nothing mentioning cookies. Oh, that's not the one I wanted. I wanted this one. Yeah, so we do check to see. So there's a few options for where we can pass. Oh, I think I realized what I forgot to do here. I need to do is pass the request object into the context. There we go. So, important step missing in the documentation here is that we need to inject into the context object the request object, or at least one of these headers. So if we look at the code here, this verify and decode that takes the context object. And there's a few options that it's kind of searching for to look for these headers. So is it a request object? Or is it a context object? Is something in the headers? Is it in the cookies? Is it an auth header? And so on. But anyway, none of that works if we don't inject the request object into the context. Okay, so missing that step. That's an important one. Let's make a note on the docs page. Was this content helpful? No, it was missing. What was it missing? It was missing step to inject request object into context for GraphQL Auth directives. So I think that's not covered here. At least I didn't see it anyway. Yeah, not seeing it in that section. Okay, cool. So that is something that would be helpful to add to the docs. But anyway, looks like we got this working. So now, if I have this valid token, then I get access to this data. Let's add an explanation or something here just to change the value of our token. So now this token is not able to be decoded. So it says, hey, you are not authorized for this resource. Your token is invalid, can't be decoded with the key. Okay, so that is authenticated. What if I want to look at the roles now? So let's try, okay, you have to be authenticated to view the user object, but maybe to view the user ID, you need the admin role. So we can apply these directives on the type or the field. And our error here is saying that we don't know what the has role directive is. So let's add that to our config object. We'll say has role true. Role enum. Oh, right. So just like the example here, we need to, instead of just passing in a string, we need to declare a role enum. Admin or user, I think, are the two that we used. And then this should be admin. Okay, cool. So now let's give this a try. So I can look at username. If I add user ID, I get the user ID because I have the admin role. That makes sense. If I look at my JWT, yep, I've got admin here. Let's take that out and create a new token. So now this token no longer has the role admin. So if I make a request with this token, I should get an error that says you do not have access to this resource. And that error is added for each of these requests. But I can still access user name because to access that, I just need to be authenticated. But if I don't send an authorization token at all, well, then I don't have access to that resource because to access user, I need to be authenticated. I can still access other information like business and so on. But as soon as I get to, so I can access business, reviews have text, and each review has a user. But as soon as I request user information, then I don't have access to that resource. And that applies also. So if I now make a, oops, where'd my token go? Here's my token. If I now make an authenticated request, so authorization bearer with my token, this is a valid query because I can go all the way down to the user name, but as soon as I add user ID, now I get the error that I don't have access to this resource because my token does not have the admin role. But if I add that, so anyway, the point I'm trying to make here is that these queries work not just from the root, not just for protecting the root query fields, but anywhere in the GraphQL selection set, those authorization rules are applied. The Cypher Params is basically an alternative to the solution you're implementing now with JWT, so you wouldn't need both. Yeah, so I guess there's more flexibility perhaps with the Cypher Params approach because I'm using Cypher and I can define my auth rules using Cypher. So maybe I have a more complex query that's like here's the user, and then maybe it's like in the graph I'm storing something like has access to, I don't know, books or something. And I want to know, okay, what are all the books that this user has access to? Maybe there's some additional level of complexity beyond just sort of like scopes and roles that I can express in a JWT claim. So it could be the case where you want to do, where you want to use both approaches, simply because Cypher Params just gives me more flexibility to express anything in Cypher. But yeah, that's a good question. So Delt says the JWT builder is very handy. Yeah, oh yeah, let me paste the link to that. Yeah, that's super useful. If you just Google JWT builder, you'll find it. But yeah, that's super nice. So both can have its use at the same time. Yeah, exactly. Yeah, so we can use both of these approaches. We just need to be careful that, for example, here we're using the Cypher params on the current user query field to return a user object. So we need to make sure that we also are meeting any auth requirements that we've defined with our schema directives as well. Yeah. Cool. So those are the two auth approaches that I wanted to actually touch on, because these are the two that I want to use, or at least starting with our schema directives, and then also looking at the Cypher params in our real estate search app. So yeah, so to answer your question about using both at the same time is yes, we will see next week, we'll see that hands-on when we add this functionality to our real estate search application. We'll see how we can use the schema directives to protect some resources based on role and scope. And then we'll start building out something like a user dashboard where I need to see only the authenticated users information. Cool. So I think that is probably enough for today. Jenny Cat wants to come out of timeout, so I think we'll call it a day there. And tune in next time where we'll dig into auth with our real estate application a bit more. Oh yeah, before we go, a couple more questions. Does the authentication automatically add to the mutations? Oh yeah, so that's one thing that we didn't cover. So we have these generated mutations, right? So for, look at our docs, things like create user, update user, delete user. How do we, because those are generated, we can't like add a directive to something that's not in our schema, right? So the way that works is if we enable the has scope directive, so I think there's a section in the docs here. Yep, attaching directives to auto-generated queries and mutations. So if we enable, I'll paste the link to this page. If we enable the has scope directive, then it's automatically attached to all of the generated mutations. And you would then need to have the correct scope for each operation. So for example, like create movie is adds the has scope directive with this convention, movie create. So then you'd also have the same for movie update, movie delete. So your JWT token would need to have a scopes claim with movie create, movie update, movie delete to give that user access to those mutation operations. Yeah, and so we'll definitely need to cover that in our real estate search app. So we'll definitely go into more detail on that one. Another question, quick confirmation. Your earlier explanation about the Cypher params means that one could use them to achieve an authorization similar to the one in this graph gist. Let's take a look at the graph gist. Entitlements and access control. Let's see. So, oh yes, this is like where we're expressing the like identity and access management rules in the graph. Let's find an example here. So administrator is a member of some group, allowed, do not inherit, company child. Yeah, so if you wanted to use this sort of approach what you would do is you would take sort of, this isn't the exact query that we want here, but this is the basic idea, is you would take this query and we'd plop it in here. So somewhere in our schema as a Cypher directive. And then we would do, in this case, we're using name, but more likely it would be some sort of like user ID or user token. And yep, this would be like Cypher params.name. So in this case, we would inject Sarah, and then this query is returning resources that Sarah has access to, where those rules are expressed in this more complex graph pattern. So yep, that's totally something that we can do. Maybe we'll try to add a more complex example like that in our real estate search app. But yeah, that's a good one. Cool. Okay, I'm going to sign off for now. Thanks everyone for joining. And if you can, tune in next time. Do this every Thursday at 3 p.m.